Welcome to our channel. Today, we're exploring the intriguing world of stress testing, an essential software testing technique that evaluates how a system behaves under extreme conditions beyond its normal operational capacity. Join us as we delve into what stress testing entails, its significance in assessing system reliability and stability, and best practices for effective implementation. Let's dive in. Introduction to stress testing. Definition: stress testing is a type of software testing that evaluates the stability and robustness of a system by subjecting it to extreme conditions beyond its normal operational capacity. Purpose: it aims to identify the system's breaking point, assess its ability to handle excessive load, and evaluate its behavior under adverse conditions. Types of stress testing. Load testing evaluates the system's performance under expected load conditions to ensure it meets performance requirements and scalability goals. Spike testing assesses the system's response to sudden spikes or surges in user traffic to determine its ability to handle unexpected load increases. Soak testing tests the system's stability over an extended period under sustained load conditions to identify memory leaks, resource exhaustion, or performance degradation. Objectives of stress testing: identify breaking points, determine the system's breaking point or failure threshold under extreme load, stress, or adverse conditions. Assess system stability, evaluate the system's stability, reliability, and resilience under stress to prevent crashes, downtime, or service disruptions. Validate recovery mechanisms, verify that the system can recover gracefully from failures, errors, or adverse conditions without data loss or service degradation. Best practices for stress testing. Define realistic stress scenarios, design stress scenarios that simulate realistic usage patterns, extreme load conditions, or adverse events that the system may encounter in production. Gradually increase load, incrementally increase load levels during stress testing to identify the system's breaking point and assess its performance degradation. Monitor system metrics, continuously monitor key performance indicators, such as response time, throughput, error rates, and resource utilization, during stress testing. Analyze failure points, analyze stress test results to identify failure points, performance bottlenecks, and areas for optimization or mitigation. Implement risk mitigation, implement risk mitigation strategies, such as scaling infrastructure resources, optimizing code, or improving error handling, to address identified issues and enhance system resilience. Stress testing process. Test planning, define stress test objectives, scenarios, and performance criteria based on system requirements and potential failure scenarios. Test design, design stress test scenarios and test cases covering various stress conditions, load levels, and failure scenarios. Test execution, execute stress tests using appropriate stress testing tools, simulate stress conditions, and monitor system performance metrics. Failure analysis, analyze stress test results, identify failure points, performance bottlenecks, and areas for optimization or mitigation. Mitigation and optimization, implement risk mitigation strategies, optimize system configurations, and address identified issues to improve system resilience and stability. Challenges in stress testing. Realistic stress simulation, simulating realistic stress conditions and failure scenarios that accurately mimic production environments can be challenging. Resource constraints, provisioning test environments with sufficient resources and infrastructure to support stress testing can be complex and resource-intensive. Data management, generating and managing large-scale test data sets for stress testing can be challenging, especially for systems with complex data dependencies. Tool limitations, selecting and configuring stress testing tools with the necessary features, scalability, and compatibility with the application under test can be challenging. Conclusion. Stress testing is essential for assessing a system's reliability, stability, and resilience under extreme conditions, ensuring that it can withstand unexpected load spikes, adverse events, and failure scenarios. By following best practices and leveraging appropriate tools, organizations can identify and address performance bottlenecks, optimize system performance, and enhance overall system resilience. Stay tuned for more insights into software testing methodologies and best practices. Thanks for watching. Please subscribe our YouTube channel.